Hello, I'm Barack Osman. I have Monday labs at 10 a.m. And today's project is basically creating different schematics and finding their truth tables and doing solving all the equations of those. So if I scan real quick, all right. So basically, we have this schematic over here where we have these different pins set to all these set to these switches, so A, B, C, and D, because I believe we only use up to D. And then we have our outputs. This is our F2, F1, and F0, because this was less complicated, so I went from least complicated to most complicated over here. Let me scroll over here. Yep. And those are set to our pins over here. That's the first one. That's the second one. That's F2, F0, and F1, I believe, if I'm not mistaken. Oh, sorry. So this is F0, F1, then F2. Alright. So, and after we run this program, which I already did over here, I'll restart that. Progress is 0% right now. Successful. So we're good. So basically what happens is, this is our first part, by the way. So I created our truth table over here. So if A, B, C, and D and all that, we have our F2, F1, and F0 in that order on our LEDs. So when all four of these switches are set to 0, F1 is 1, which is same over here. And if we just randomly swap a couple, so this is our 1, oh, 0, oh, this is our A, yeah. So 1, 0, 1, 0. If we look over here, that equates to our 1, 0, 1, 0 over here, which means they're all off, which is the case over here. And let's just try one more. We can try 1, 1, 1, 1, 0, which is our 1, 1, 1, 0 here. So it should be 0. So off, on. And as we can see, it is off, on here. So we'll do one more. Why not? So I set A to 1. The other three are 0. So that would be our 1, 0, 0, 0. So over here, we get 0, 1, 1. Which over here, 0, 1, 1. So our system works for part 1. And I will be doing part 2 and merging the videos, hopefully. So we'll see how that goes. And just forgot to add this part in the first section of the video. Here is our simulation for our truth table. So you can see that A over here is 0, like the first 8 digits, options, I guess, are 0, then 1. Then B is 4 zeros, 4 ones, 4 zeros, 4 ones, and vice versa. And we can see that our F values over here give us the same ones as the truth table that we made over here. So everything works perfectly. Alright, so I'm doing my part 2 of lab 3 right now, and as you can see right here, if I swap the camera, you can see that over here I have my circuit where I have the W, X, Y, and Z inputs, which I'll invert it just to make it simple and nice. And I have my outputs over here from F15 to F8 over here. I've done that because the quarters prime that we have only has so many LED outputs, so I wasn't really sure if we needed output pins, but it didn't work for some reason without output pins, so I assigned them anyways. So I did the first 8, then I'll do the other 8 later. So as you can see in my simulation waveform editor, I set W, X, Y, and Z to what we had in our actual truth tables over here. And similarly over here, we have the same truth tables for our F15 to 8 that we did over here from 15 to 8. And if we run our truth table for 7 to 0, okay, so after editing our circuit, so we have F7 to F0, so the second half of the equations that we had, or like, I guess, yeah, equations, I guess. Okay, so sorry about that. I made an error where for W, I did 9 zeros and 7 ones instead of 8 and 8. So fix that real quick. So we have our W, X, Y, Z, same values as the truth table that we have over here on our second screen. And as we can see, so our F7 to 0 go pretty much the same. Well, not pretty much, it's exactly the same. So over here, up here, getting truth tables, giving us an exactly diagonal line of ones if we combine the two graphs. So this, our simulation clearly works, and it's working great. So there we go.